We'll begin to tear down the MT3X by removing the various knobs that we can from the top surface. The master section has little red decals, whereas the rest are cream in colour. You'll notice that in this model there's a couple of missing knobs. I'm hoping to replace them with knobs from a spares MT120 that I have. The colours might not match exactly, but it'll be close enough. Things like these fader caps, I'm just going to pull off from the top with a little bit of prying with my fingernail. Likes of these will also come up. We probably could remove these mini slider caps, but it's going to be easier once we have the front case off. I'll go away and take the rest of those off and come back when we can remove the screws from the rear. The locations of the screws are in 1, 2, 3, 4 holes along here, 2 here, and 1, 2, 3 along here. The screws are all the same, about 35mm in length. I'm using the Phillips head screwdriver. If you had JIS, that is Japanese industry standard screwdrivers, that would be better. But unless the screws are very tight, there's no real disadvantage to using Phillips. Using Phillips, you are slightly more likely to strip the head. 2 of the screws on this are set into broken mounting posts, which is why I have 6 screws in my hand and not 8. Change of camera angle here so you can see what it's like when we first open it up. Most of the connecting cables are along this back edge, so tip it along that edge. I can remove some of these plastic knobs now. This protector isn't connected to anything, so I could just lift that off just now. I suppose the main thing I want to do now is disconnect these 2 halves, just in case that falls over or something. I can see 4 cables here, and they have different numbers of cables, but there's a little bit of opportunity for me to get confused when I put them back. So what I've taken to doing in situations like that where you have lots of white connectors going into white headers is to colour code them with Sharpies. So you can use any colour scheme you want. I'm going to make both the header and the connector of that one brown. This one I'll go for black. This one here, the connector's red, although only one cable is red, so I'll make the header red as well to make that obvious. I'll go for green in this connector here. Then we have 2 connections from the power supply up to this display board here. They have such a different number of cables going into them, I don't think I need to label them. We have a connection to ground here, so there's a little double pinned connector just up in the top left corner of this bottom board. There's one beside it as well, to a ring connector. The screw here, it's soldered in at this end. So that's a 10mm long screw, same thread angle and spacing as the screws that were connecting the 2 halves of the case. It's got a little washer on it, there's a little star connector below it. This is just to ensure the earth connection with an exposed area of track on the bottom of that PCB that's connecting everything to circuit ground there. At that point, the 2 halves are separate. One of the most common things that we'll be doing with something like this is trying to change belts and so on. So I'll get the camera above here again and we'll focus on getting this transport out. This bunch of cables here, which I guess is to do with state detection switches like this leaf switch that I'm paying just now, pitch control and power supply for this motor. They're all coming down in a bunch underneath this board here, and then the cables that are going to the play record and the erase head are tucked under this bit of shielding, so I'll remove those first. Shielding's attached by 2 screws. Same type as we removed before, without the washer or the star connector. Notice that we have this little metal part, which is both touching this ring connector here and making a solid connection to this metal area here. And there's another one of these little metal bits that makes good contact with the shielding, I guess, down here in this bottom left corner. This board here, there's 2 screws along the top, 1 in the middle, 1 in the left corner. For safety's sake, I'll colour this connector and header this light blue Sharpie, make it a little bit easier for me to figure out what's going on when I put the unit back together. Now there is a ribbon cable. The way these work, you can lift a piece of plastic here and pull the cable out. I, wherever possible, will try and leave those in situ, because if those protruding pieces of metal get at all bent, it can be actually quite difficult to put them back in. So I'm just going to tip that over to that side. At that point we can see that these cables circling around from the transport We've got a long connector here and a shorter one with just 3 wires. These white cables seem to pertain to the erase head. You can see that those are very similar looking, so I'm definitely going to colour code those. I'll make these upper ones red and the lower ones black. This cable, coming from the record head I think, that goes into a red connector from a red header already, so there's nothing else I need to do there. I'm putting force onto the plastic, not the wires themselves. This one feels stiffer, so I'm going to use a flathead screwdriver just to pry that up a little bit until it comes away by hand. The cables themselves are very thin, so I don't want to put any stress on them directly. Down in this bottom left corner we have a ring connector. I think that's probably the earth connection to the head housing. And then there's another ring connector connecting the metal chassis of the cassette player to circuit ground in this corner. Other than that, there's these 2 screws with no ring connectors. We've got a broken mounting post there, so that's just going to lift off. I'll remove it later. The broken mounting posts, by the way, I can fix them. You put them back in place with super glue to begin with, and then I would go back with spin welding to reinforce the joint. I've made videos about that. I have a playlist called Plastic Work or something. I'll put a link up on the screen. So you can see that broken mounting post there. Not a style of transport I've seen before in a Yamaha. It's most reminiscent of the sorts of transports that I've seen in mid-period Fostex stuff like the 260. 2-motor design. The wheel motor is handled independently. The capstan motor has teeth which drives gears and a lever driven by a solenoid to change modes in terms of whether the head array and the pinch roller are high or low or whatever. We don't have a pinch roller on here. Has that fallen off? Maybe I'll find it later. That could be a problem in terms of getting this to work properly. We'll see. I might have a solution. I've got pinch roller arms and so on from other units, which I might be able to kind of bodge into position there. I've bought another MT3X second-hand, a faulty one. It's always good to have 2 of these really. Whichever one is worse, you can demote to being a spares donor. And this one does have the pinch roller arm, so I'll just show you this. There's a clip here. If I just pry that with a flathead screwdriver, that'll allow this entire part to slip off. And the spindle for the pinch roller, I think it's going to push back through from the back. I haven't done this in rehearsal or anything. Let's pull that out. So we could replace that. I'll probably clean this one. I've never actually seen one of the late 80s, early 90s ones go really bad. I'll probably put that in some MG Chemicals Rubber Renew, wipe off any excess rubber, clean it again with Windex, rinse it with water, dry it with a paper towel and put it back on. When we put it back on, it's going to slide through from the front. This spring here is going to need to go into this little recess here, because that is how, when the head array is lifted by the gears at the back, the pinch roller comes with it. The purpose of the spring is so that when this touches the capstan pin, then this will give you a bit of give, so there's tight contact, but it doesn't actually prevent this from coming all the way up so that the heads touch the tape. So if I slide this down, to pull that clip out of the way a little bit, line it up with the hole, and if I just lift up the clip again, push that down, and that's it, back in place like so. So you can see where it gets to the point where it touches the capstan there, but if I keep on pushing it doesn't get any tighter because there is a bit of leeway because of that spring underneath. I'll put it up on the screen afterwards, exactly whose symbol that is, but it's an MMU5U2RWJ. I can see that it's got a B, A, a plus and a minus input socket. So this B and A configuration means that we have a resistance between there, and the higher the resistance is, the higher the speed. I think this is a dual speed model anyway, but if you ever see a motor like this in a single speed unit, you can modify it to do dual speed. It's generally compatible in my experience with the Mabuchi motors that are found in Tascams. You just need to watch out that the pin ends are in different places. Like on a Tascam, these left two would be minus and positive, and the right two would be the resistance network. But here we have positive, negative, the other way around and off to the right, and the resistance is here. Because we don't have any idler tire and we have direct drive for the real motor, then there's really just the belt and the pinch roller to be replaced. The belt actually seems a little bit dry, but it's okay. Looks like we have two small screws, one here and one here, that need to be removed. I'll be using a smaller size of screwdriver. So with those screws removed, you can see that this part should go outside these metal lips. These little indents, it should prevent this from sinking any further if you place it back correctly. Plastic part here for this flywheel, the end of it to rub against. The folded length of that is in the region of 125 millimeters. Probably 120 millimeters would work okay. Where you would buy that, it really varies where you live. I get belts from two places. One is a place called GB Audio, gbaudio.co.uk. They're based in Edinburgh. It just means I can order stuff in and get it the next day, and the stuff they have is good. I also do buy stuff from AliExpress. Both GB Audio and AliExpress can give you belts based on that folded length. Double the folded length to get circumference, which is what GB Audio will give you, and pretty much all the AliExpress sellers are looking for folded length. They'll also tell you the width in that direction. 3 or 4 millimeters is what I would tend to buy. Less than 3 millimeters is too thin. 4 millimeters, some of them, that could probably accommodate a 4.5 millimeter belt, but most pulleys aren't wide enough to accommodate a thicker belt than that. I'll proceed to gain access to the underside of these boards. This is something you would need to do if you need to replace some capacitors. Look for a hairline crack in the board if the unit's been dropped. Other scenarios I can't quite think of just now. There's some metal shielding in this bottom right corner that seems to be separating signals between this board and the one below it. I can see two screws here. Perhaps this one here is part of this as well. Well, let's detach the board. Looks like the shielding's actually soldered on here, just 2 tabs. I'm kind of curious to see what's under there, so I will just heat up the soldering iron and take that off. I've come to despise solder pumps and use desoldering braid more or less exclusively. And we've got a little twisted tab here that I need to turn. So it's parallel with its slot, and there's another twisted one here. Sometimes even after desoldering you need to give these things a bit of a wiggle with a pair of pliers. There we go. So there's a microcontroller. If that ever went, you'd probably be gubbed, but there's an op-amp, some electrolytic capacitors and diodes and so on, which are fairly fungible that you might want to replace if you ever had a problem with an area like that. A generalisation I'd make about the Yamahas that I've worked on is that the build quality appears very good, but in a way where they're making it quite hard for you to get access to the machine. There's all sorts of screws and fastenings and things like that, soldered in shielding to get past. I will just put that back in now that you've seen what's underneath and how to remove it. So when we come back, this will be back in situ, and we'll start to remove this board from the base of the plastic case. As before, these ribbon connectors I'm just going to leave that all joined together dangling, just to avoid the risk of being unable to or spending too much time trying to put those back in. So there doesn't seem to be very many screws holding this down anymore. There's one here that I can see, and there's another one of these little metal inserts for connection to ground here. At this point, the board seems to be mostly connected via screws along these sockets here. I'll just change the camera angle so you can see me take those out. Please excuse the handheld footage. You can see that there are 1, 2, 3, 4 screws, one above each pair of these RCA sockets. I don't know how well you can see in that light, but there is the figure of 8 power inlet in there for the AC wall socket, and there was one screw there. All the screws are pretty much similar. They're about 15mm in length. The style of them is very similar to the brass looking screws we've already removed. They're just black to blend in with this black plastic. The transformer is soldered in at both ends. I'm not going to desolder that. I think it's simpler to just remove the transformer, both these daughter boards and this main bottom board, all in one go if you need to access this for soldering or whatever. So I've removed 4 screws, 2 from this side and 2 from this side of the transformer. The bottom right hand corner, as we look at it, is going through this plastic bit of it's not quite shielding, I suppose it's to protect someone from electrical shock more than anything, stop dust getting into the transformer maybe. The screws themselves are a little bit thicker than the others that we've been removing. They have these sort of domed caps, they're a bit sturdier to accommodate the weight of that transformer, but we are still using the same size of screwdriver as we have for everything so far. We'll then lift out of there, we then tip this forward, and this will come away as one big unit. There's some glue holding this shielding down, but not that much, it's not that critical. Just seems to be glued down a bit more, but I think I can lift that fairly harmlessly, allowing me better access to fix broken mounting posts and get a lot of the dust and grit and stuff out of here. Now we'll move on to tearing down the upper half of this. We have these plastic button arrays for pushing the tactile buttons beneath. This unit's pretty dirty, so I'm definitely going to want to get those out and clean them with washing up liquid will do. I find Windex is pretty effective, so I'll wash them at the same time as the knobs that were on top of the faders and rotary controls. 2 screws each. Screws are of the same type that we've already seen. Next, let's get these daughter boards with the input sockets on them. This one to the left has 1 screw with one of these metal structures that we've already seen, and this one on the right has 2. This board with sockets at the top appears to be held in both by clips here, I'm moving with my thumbs, and also 3 black screws. I assume they're going to be the same kind that went into the back of the bottom board. Yeah, they are. So there was some sort of metal plate in between those parts there. That's what it looks like. I'm going to cut this zip tie, just making sure that I don't cut any of the cables beside it. Got a bit more space. I'll leave this ribbon connector connected, just so I don't have any problems reinserting the cable. You can see that there are a graphic of a screw beside the holes where we're meant to attach this board to the upper plastic case. That's in contrast with holes like these. There's no graphic of a screw, and that's to show that these are holes where longer screws are coming through the bottom plastic case and into these mounting posts. So we have 2 on this row, 2 on this row. The one on the right is holding down 2 ring connectors for connection to common ground. 2 here, 2 here, and 1 here, so 9 screws. All of those screws were of the same type that we've looked at before, except the one that goes into this earth connector here, which is the same with the exception of having a washer on this side and a star connector on the other, much like the screw connecting to a connection like this on the lower board that we already saw. That's going to lift up now. I'll just tip these daughter boards forward slightly to get those out. So now we have an opportunity to remove the rest of these plastic caps. With all those caps removed, I can just pick up this bit of shielding. It is shielded here, you can see the ring connectors, and there's a conductive surface here. One of the things I'm slightly iffy about Yamaha's is that some of them use a foam material as a dust protector. I'm pleased therefore to see that on this model it is felt, which doesn't rot over time in the same way that foam does. We have a piece of shielding underneath where these input sockets would have been. Really all that remains now is to remove this display. The two screws attaching that seem to be a little bit longer and a little bit thicker than the others, so keep those separate. It's so complex it looked like it could have been vacuum fluorescent display, but I don't think it is. I think it's liquid crystal display with a backlight. The door is just held in by one spring and screw. The hole goes through the screw hole obviously, and you can see there's a very slight downward curve to this leaf spring. You want that to be pushed downward at that point. If I just turn the door through an angle like that, we can get it separate. And that just gives us better access for cleaning. I mean, you can see the amount of dirt that's built up behind some of these knobs.